Yeah, well, welcome back to differentiation of inverse function, part two. And in this part two, it will be all solution to problems, different problems, questions, okay, on inverse function. So let's look at the question one. We have to show that the inverse of cot, okay, is this, okay, and this B part of one, we have to show that the inverse of cosec, which we call CSC x, is what is minus is this. Okay. Straight to the solution. Number one, A part. Can we call this one y? Let's call it y. Let y be equal to cot, inverse of cot. And I've told you when you are dealing with inverse function, what you can do to negate the inverse is to take the whatever you have here, take the cot of both sides. Okay. If it's sine, you take the sine of both sides. So take cot of both sides. Take cot of both sides. And that will be equal to cot y equal to what? X. And that will be equal to x equal to what? Cot y. Okay. And if you take a derivative of cot, then can you do the differential coefficients? X is a function of y, then we can get the x, the y. And the differential coefficient of cot is minus cosec square y. Okay? So what we now do now is for us to turn this one to what? To cot, so that we can substitute for that. And then from the identity, we have 1 plus cot square theta cos square y is equal to what? Cosec y. So we can substitute for that, and that will be equal to x dy equal to, substitute for that. Okay, so that is what we're having, minus into bracket the expression cosec square y is what? 1 plus cot square y, which is equal to what? Minus into brackets 1 plus cot is what? Is x. That's x squared. Okay, can you take the inverse of both sides? So because we are looking for the y, the x, and we have the x, the y. So take inverse. So that will be the y, the x. And that will be equal to what? Minus 1 over what? 1 plus x squared. Okay? Yeah. So that's just that. Ideally, it should have been 1 over. When you take the inverse, it should have been 1 over minus into bracket what? 1 plus x squared. Okay? So the minus can be anywhere. It could be up, it could be down. So this is more better. So that's that. And that is done. Let's go to B part. Do likewise. Call this one y. Let y. So let y be equal to cosec, inverse of cosec, which some people call CSC. We can write it this way. It is correct. Okay? So can you take cosec of both sides so that we can negate this one? We can cancel this one. So that will be cosec y equal to x, which is s equal to what? Cosec y. Okay? Can we find the differential coefficient? X is a function of y. So we can get the x, the y. And when you differentiate cosec y, okay, in one of the videos we have explained that, okay, we have proved how we can get this one. Derivative of this one have been explained in one of our videos. So if you have not watched it, please do so now. Okay. Derivative of cosec is minus cosec y cot y. Okay. So that's that. Minus cosec y cot y. So what we now do now, we want to ensure that everything we have here is all cosec. So then we have to substitute for what? For cot y here. And how can we get that? Don't forget, in one of our identity, that we know that 1 plus cot square y is equal to cosec y. So we can make cot the subject because it's a cot we want to move here. Okay, we already have the replacement for cosec here, which is what, x. So we want everything here to be what, to be all x. So cot, we take the square root, cot y, we equal to square root cosec squared y minus 1. Okay, so my dx dy now, my dx dy will be equal to minus cosec y square root, the cot is square root cosec square y minus 1. So let's now make a substitute for the cosec, which is what, x. So the x, the y is equal to minus x square root s squared minus 1. Can you take the inverse of both sides? So if you take the inverse of both sides of the equation, you have minus 1 over x into bracket 1 s squared minus 1. So that's the differential coefficient of cosec. Why am I using y? Yeah, that's the differential coefficient of what? Of cosec x. So that one is done, and we have gotten it. You can see is the same thing. Okay, so that's that on that. Then the next thing to do is to, I've told you, using identity is very, very important. Trig identity is very important. It's applicable, highly applicable in differentiation, in integration, okay, in other aspects. So let's take question 2. Question 2, we'll do likewise. Let's call this one y. So y is equal to arctan x over a. Can you take the tan on both sides for question 2? Y equal to arctan this. So what we'll do is this. We're going to substitute for this. That will be arctan b. Where my v is what? X over a. So it's better to do it this way to avoid that confusion. Okay. So then the y, the v, y is a function of b, and b is a function of x. So this will be equal to 1 over 1 plus b squared. Okay, and then you substitute your v here, that will be 1 over 1 plus. My v is what? X over a squared. And that will be 1 over a squared plus s squared over a squared. Okay, and that will give us, if you take the inverse of this, you have a squared over s squared plus you have this a squared over s squared plus s squared plus a squared plus s squared. So that's your dy dv. Okay, then let's get the v dx, which is equal to what? 1 over a. A is a constant. You only differentiate the x. Then your dy dx is equal to dy dv times the v dx. Your dy dv is what? A squared over a squared plus s squared times the v dx is 1 over a. So a here will cancel, and then 1 will go here. So you have what? A over a squared plus s squared, which is done. We'll quickly go to the b part. Go to the b part. So let's give it letter. Let y be equal to what? Arcsine x over a. So, and that y is equal to what? Arcsine v, where v is equal to what? X over a. So can we get the y dv, the y dv, which is what? 1 over 1 minus s squared, which is what? V squared. Okay, then we can solve this. 1 over square root 1 minus, my v is what? B squared, that will be s squared over a squared. So if we solve it, it will be this one times this one. That's a squared minus s squared over a squared. Okay, square root. They have one on top. So with this one on top now, it's going to be, it will flip upside down, and don't forget this will be equal to 1 over square root of this a squared minus s squared, and square root of a squared is a. When you have a square root of a fraction, it will be square root of each of the fraction, each of the fraction numerator. You have a square root of numerator and denominator, so it's going to be square root of numerator over square root of denominator. So that's what we have here. And then with this one here, it will be equal to what? A over square root a squared minus s squared. And your dv dx now is 1 over a. Okay, so finally your dy dx is going to be a over this times dv dx 1 over a. So this one we cancel. Then you have what? 1 over square root of what? A squared minus s squared. So that one is done. That one is done. Okay, that's that. That's that on that. And don't forget your dy dx will be what? Will be the y dv times dv dx. So that's what we have done there. Now let's take one more question. So if y is equal to this, show that this one is equal to this one. Okay. When you are showing something, you need to observe what you have. You can see dy dx. Okay. And then after that, they multiply dy dx by this expression. So we need to get the dy dx first. That's the first thing we have to do here. So the y dx here, I mean the y d theta, okay, is equal to, this is the product rule. The two items is product rule. So whereby you keep one constant, you keep this one constant, and you differentiate this one, which is times 1 over square root 1 minus what? 1 minus theta squared. Then plus the one which you have done here, which you have differentiated here, you keep it constant, arc sine theta. Then you differentiate this one, which will be equal to half. Okay, half the power, half go to the front over 1 minus what? 1 minus theta squared, and then half minus 1 minus half. Okay, and then times the derivative of the inner function times the derivative is what? Minus 2 theta. Okay, so the 2 here we cancel. For dy the theta. This one and this one will go, so we have 1 there. Then minus here, so minus theta, it will bring theta here. So theta, and then we will be observing your questions, be looking at your question. Theta, followed by this one. This is square. This. Let's just write it there. Theta, arc sine theta into bracket 1 minus theta squared over minus half. So that's my first differential. Okay, that's my first differential. So the next thing to do is to multiply that by 1 minus theta squared. Multiply the y d theta by 1 minus theta squared, and let's see what we're going to get. So that will give me times 1, that's 1 minus theta squared. Okay, and then minus theta arc sine theta, and don't forget that this one and this one, they are the same, so they have the same base. Then you subtract this half. Okay, you are multiplying plus 1. Half plus 1, that's what? That's half. Half plus 1, that's half. So by the time you do it, you get what? You get your 1 minus theta squared. Let us rearrange it now. This is half, so I can bring it to the, okay, I can leave it there. So that will be minus theta. Okay, this one, square root 1 minus theta squared, and then arc sine and sine theta. So this one from the question is the y. That one is the y. Check your question. Check your question. That's y. That's y. Okay. So finally, you have 1 minus theta squared minus theta is here. Theta is here. Theta is here. Yeah, let's check the question. This n, where is it coming from? Let's check the question. Yeah, sorry, this is not n. It's not even possible to have n. So this is theta. Yeah, this is theta here. Yeah, that's theta there. So that will be theta what? Theta y. So, and that one is done. That one is done. So that's that on this question. So the first thing, question like this about show, look at the target, what you're supposed to do. The y theta is there. That means that's the first thing you do, which we have done. And if you look at the question, it's a product rule, whereby you keep one constant, you differentiate this one, which is here. Okay, then plus the one you kept constant, you differentiate that, and you differentiate, you keep it constant, and differentiate this one. Okay, so that's what we have done here. Okay, then you have this for the y theta, then you multiply, and that gives you your answer. Okay, so at this point we drop the curtain on inverse function, differentiation of inverse function part 2. So please, if you're still having, you can watch the video over and over. Okay, like the video, click on like button. Okay, and hit the subscription bell so that as we upload, you get notified. Okay, also invite your friends also to also join this channel. Okay, then thank you for doing that. Thank you for doing that. Okay, join me for the next video on the next topic. Yeah, join me for the next video on differentiation of implicit functions. Okay, thank you.